This conference will now be recorded.
Hello, I want to welcome you all on our next DigiFoF webinar series. Today, we'll be discussing about simulating event logs in production processes. My name is Zbigniew Misiak, and I'm your host. As in the case of previous webinars, if you have any questions, please feel free to expand the GoToMeeting, GoToWebinar panel and use the questions functionality to ask those questions. At the very end of the session, there will be Q&A part where Anne, our presenter, will be answering your question. And since I mentioned this, today our presenter will be Anna Zumereder. She's a member of OmiLab team, and here you can see contact details. And today she'll be telling more about those aspects of production processes. So, floor is yours. I'm giving you presenter right. Please continue from here. I hope that you got the invite.
Hi, everybody. Thank you very much. I think you should see my screen now. Is it correct?
Yes, everything looks perfect.
Great. Then we are good to go. Today I will show you how we approach production processes with an OmiLab laboratory experiment in order to create and simulate event logs. And in specific, I would like to show you the laboratory setup and the demonstration for 3 digitization characteristics within a paint production use case sample. First characteristic is the digitizing the production process sequences. Then we will proceed with digitizing the raw material warehouses, and we will finalize with digitizing the product information. The OmiLab Innovation Corner allows to tackle design-related questions and also questions for production processes based on 3 layers. So for instance, on the business layer, you might ask yourself if you do need to extend your existing business model or if you create a new existing business model. On the conceptual layer, you might ask yourself if the organizational design you're using is correct. Do you need another organizational design? And on the bottom, on the proof of concept layer, you might ask yourself, how can your digitized process model work? And today's major topic is how to simulate event logs in a production process with a physical model that I will show you afterwards, and also with Petri nets. And we will now start with the first characteristic we identified for production processes, and this is about digitizing the production process sequences. In order to clarify how our laboratory setup looks like, on the left-hand side, you can see a picture of a real-world paint production, which is mapped to the lab setup by applying simplification and also abstraction. And this is done to reduce the physical space as well as the complexity and to focus on the relevant aspects of the business model. An association in form of a mapping to a tea production sample was chosen for the laboratory setup, as this is provided for common understanding and to pave the way for transparency and better understandability. And this results, as already shown on the right-hand side in the OmiLab laboratory setup, which has similar characteristics compared to the real-world production process of paint. And for instance, such a similarity would be that something is produced in a larger amount and then filled in several buckets, and those single buckets are sold to the customer. Here you can see the real process model with BPMN, and based on this quite complex process, the idea is to reduce the complexity, and so the focus lies on the key aspects, and therefore we designed a very simple BPMN process consisting of only 4 elements and 4 tasks, and this is to depict only the major production steps and to ease and simplify the whole process. And our process consists of the major paint production, the laboratory approval, the filling station, and the finalized outbound. Now there are 3 major aspects important for simulating the production process, and in specific for our production process sample. And the first one is that we have a mapping from the real world to the digital world. So from the real mixer to a BPMN task. And the usage, the second aspect is the usage of logs as an extension of the digital model. And the third aspect, the final aspect, is about how to access these logs from outside. And to cover these aspects that I currently mentioned, we have introduced the concept of event-based logs. And this is used to realize timestamps, and those timestamps are collected in a database and serve as a foundation for retrieving further information. And in order to generate these timestamps, we have 3 options that I will now present in more detail. The first option, how to simulate production processes, is with PetriNets. And you can create those timestamps and events with PetriNets, as PetriNets offer the functionality to create timestamps for each production process steps, abstracted in form of transitions. And we use PetriNets as this allows us to create a huge amount of timestamps within a short amount of time by simulating the process. And I will now show you how such a simulation could look like. And therefore, I will open the process in BApp. And here you can see again the process. The process you have seen before in BPMN is now mapped to PetriNet. So you can see the tasks in BPMN are now transformed to transitions. And those transitions include the information on creating timestamps. And when I now run the simulation, I can create timestamps in a quick way, and I can see those timestamps, and for sure those timestamps and events can also be saved to a database so that they can be further processed. And PetriNets allows you to create iterations however you would like. So you can create either 100 timestamps and 100 runs or even more. And from a technical perspective, this is shown in the notebook of such a transition. And here you can see when the transition is fired that there is an effect. And this effect writes those timestamp and some additional textual information to a log file. Then we come back to the presentation. And I mentioned before that there are, in general, 3 options to create such event logs. And the first option was PetriNets, and now you can see the second option. The second option is about simulating event logs. And this can be done also with a touchpad interface. And this approach might be of interest if you do not want to create a huge amount of timestamps, but for instance, if you need simulated event logs for a very specific case. And now we come to the third option. The third option would be the digitization of the production sheet in order to generate timestamps with RFID tags on such a production sheet. And this can be done physically by adding simply such a RFID tag onto the production sheet. And these RFID tags can then be used in connection with RFID readers to create timestamps for the digitized production sheet at each production station. And the question now is, why do we need such timestamps recreated with Petri nets, touchpad, or RFID tags? And the simple answer is that timestamps can help you in answering following questions supported by models. For instance, the first question would be, what is currently ongoing in the order production? Then you can also answer, can we finish the order as planned? Or what might be of interest for customers is when are we ready to start with another order, with the next order in line? On the left, you can see the monitoring of the production order process, revealing information on what is currently ongoing in the order. And you can see that there is only information displayed that is already in production. So only the process steps that are already in production can be evaluated. And whereas in the middle, you can see a forward-looking prediction, for instance, for a specific order or also a production line. And you can evaluate predictions such as in 2 hours or 4 hours from now on, for instance. And different perspectives such as optimistic, moderate, or pessimistic can be considered. And this allows you to simulate, for example, if the order is on track on the filling production process step, for instance, or if there are any delays that must be expected and that must be dealt somehow. In addition, specific orders can also be queried. So, for instance, imagine you have a web shop and you would like to know if you can produce the order of customer 1. For answering this question, you can use the timestamp data for simulating if and when the order can be started and produced. And based on the query output, it might be necessary to adopt the sequence of current orders or the production, or simply to react to the customer to say that he or she should be a little bit patient, as there are currently a lot of orders ongoing. And finally, after collecting all the timestamps, the data can also be shown in a dashboard. And I will now show you how such a dashboard looks like. And I will also show you how we realized this scenario that I presented right now in the OMI lab. And I will now stand up and go to the laboratory setup and show you how this process that we currently discussed can be digitized with RFID tags. And therefore, we use a digitized production sheet. And to make it very clear, we attached an RFID tag onto this production sheet. And in order to go through the process, we start with the mixer and prepare everything for the production. And therefore, we attach the production sheet with the RFID tag to the RFID reader. So that this step is already captured. And we would normally collect all the ingredients and mix these ingredients and prepare these ingredients. And afterwards, we test the production in the laboratory. Again, we can attach the RFID tag to the RFID reader. And then finally, the product is finished and hopefully also approved. And when this is the case, we can use cups, small cups, for filling the whole product in smaller cups and entities that can be sold. Then when this filling is conducted, we go to the outbound and save and store these products in the outbound warehouse until they are needed. And when I now go back and we have a look at the dashboard view, we can now see that the stages were run through, and it can be seen that we collected such a timestamp at 14:20 today. And we can also go to the process view, where you can see the process and all steps that were conducted, and also the ID of the number for the order that was used. Now let's get back to the slides. And we are ready to go for characteristic 2. And this is digitizing the raw material warehouse, and we will go into more details right now. So the raw material for our sample can be divided in ABC material, and B stands for material where the amount of pieces is relevant. So for instance, in our case, we have tea bags and sugar bags, and also very small milk cups. And the C material in our case stands for the material that is very cheap and that should be available at any time, for instance, such as waters. Water and C material is stored in silos for our example, and the introduction of slots for B material allows us to abstract from the real world to our laboratory setup, and our experiment slots are equipped with RFID readers, as you can see on the picture on the bottom. And those RFID readers allow us to create timestamps when simulating a slot event. So every time something is taken from a slot, the event is captured by such an RFID reader and the production sheet RFID tag. What is important, we follow the approach of digitizing the slots for our sample, and therefore we first digitize the material slot with RFID, and second, we digitize the material collection process. Notice that we do not digitize materials and material flows. And as we digitize the material slots, the process is kind of handed over to the material. We decided to design sub-processes showing different combinations of materials that are used to create a specific product. And those digital models representing the material collection can then be used to create timestamps for the slot events, in addition to the timestamps for the process steps we discussed before. The database is then not only filled with the simulated timestamps, but also with the simulated timestamps from the material collection. So not only from the processes, but also from the material collection. This means that what I showed you before is simply extended with the material collection. And the idea is that the collection process model is the foundation for for the raw material slots and the materials picked up. Each event is captured in real time and deduces the material in the raw material status. And based on the orders and the bill of material, a collection process for the raw material is created. And these collection process models are then processed, supported by the digitized slots. So here on the right-hand side, you can see 3 potential collection process models for creating an Earl Grey tea. On the left, there is Earl Grey tea with sugar. In the middle, there is Earl Grey tea with sugar and milk. And on the right, you have Earl Grey tea only with milk. And as already mentioned before, Petrinets can be used to create such event logs, and therefore, additionally, the raw material is digitized by creating timestamps for each raw material event. And while simulating this Petrinet, log files are created based on the digital world. These log files can be used for further analysis and might be helpful for redesigning warehouse layouts or other raw material requirements. And I will now again show you in B-up this process, and additionally to the 4 transitions that we had before and that we also had in the BPMN model, we have now additionally 3 transitions for the specific collection process of creating an Earl Grey tea with sugar and milk. And again, we can run these iterations and simulate event logs that can be used for further processing steps and evaluation and also analysis purposes. And in this case, we use Petrinet, as Petrinet allows us to integrate such a processing functionality compared to BPMN that does not allow such a processing. And again, the digitized slots can be further used to create timestamps by using a tablet. For instance, by using tablets in each raw material slot, so that they serve as a touchpad operated by user input, and the digitized production sheet can simply be connected with such digital devices. And for instance, when a specific slot is visited, material is picked up, and simply pressing a button on the user interface also deduces this in the raw material state. And instead of using Petrinets or tablets, also raw materials can be captured by digitizing the slots, and this can be done by directly introducing RFID readers mounted at each slot. And I would like to show you now how the raw material events captured with Petrinets, user input, or RFID can be visualized with the dashboard. And I will also show you again how this works in our OMILAB laboratory example. And here you can see that the dashboard visualizes an overview about the last slot events and helps you to determine the raw material status. And now let's go again to the dashboard view and to the warehouse view. And again, when we take our production sheet we first go to the mixer that must be prepared in order to be able to create a product. Then we collect the material required for the product, for instance, camel tea. And as our production sheet says that there is also sugar and milk in it, we also collect sugar and milk. And when everything is finished and mixed and prepared, we can go on with the laboratory testing. And after this laboratory testing is approved, we can use again the small buckets to fill up the product in smaller volumes. And finalize is the final step is to store these products and prepared products in the outbound warehouse. And when we now go again back to the dashboard view, we can see that those materials, chamomile, sugar, and milk were used. And we can also see that the material status was deduced by 1. So before the camel material had a status and a quantity of 18, and now as one element was deduced, we have a status of 17. So a real time status is captured here. And now let's come to the third characteristic in production processes. We would like to digitize the product information. And the focus for digitizing the product lies on the digital information in our laboratory design. And therefore, we introduced digitized product buckets, which are the small white cups. And these should abstract the real paint buckets that are normally used to sell the product and capture the simulated production process events and also additional product information if required. And in this case, the timestamp data collected during the process execution, as well as the timestamp data collected during the raw material events, can then be used to digitally extend the product information. This can be realized by attaching RFID tags, as you saw the white cards on the buckets, to the product. And for sure, not only those white cards can be used, but also stickers. However, the white cards are better to visualize and easier to understand for our example purpose. And here you can see now how everything fits together. The digitized production sheet holds the production data, which is finally written to the product information so that the RFID tag on the product bucket can be read from anywhere, also from a local shop, for instance. And this kind of closes today's journey of simulating event logs, ranging from digitizing the production process over digitizing the raw material warehouse, and finally to digitizing the product information. And the product information can then be retrieved easily. Not only is this beneficial for the producer, who can, for instance, eliminate products that are related to a broken charge of raw material, for instance, but also for the customer, who can easily track the creation of his product. And again, I will show you in our sample environment how this is done. So after collecting all of the data and after creating the product and approving the product in the laboratory, the product is filled in such little buckets, and those buckets can be used to write the product details onto the RFID tags, and therefore we have another RFID reader that allows us, an RFID writer that allows us to capture the whole information collected throughout the process onto these product tags. And then normally each production process assumes that those are delivered to the customer or to a wholesaler, and therefore we assume that those products are delivered to a shop or store outside of the production area, and there it can be, the information on the tags can be read with every product, every RFID reader, and again this information can then be read on the dashboard so that the customer sees when the material was collected and which steps were run through during the production. And as also the order ID and the bucket ID are captured, potentially problematic buckets or error noise products can be sorted out also on the customer base. And that's it so far what I wanted to discuss today with you. I thank you very much for listening, and in case you have any questions, please let me know.
So as Anna told, if you have questions, do feel free to expand the panel and use the questions or maybe even better chat functionality. Let us know. I have one question. You used both Petri nets and BPMN. Could you tell a bit why those two approaches and how did you see their usefulness? Because I saw that in the dashboard you had both visualization pretty similar to BPMN with starts and end events, but also visualizations with Petri nets. So why did you choose both of them for those purposes?
Thank you very much for the question. In my view, Petri nets is better to visualize the process for business people and for people that are used to the domain, so for domain experts, for instance. And Petri nets are rather used for technical experts, and also for the production of such event logs, as those have additional functionalities that Petri nets simply do not, that BPMN simply do not provide compared to Petri nets. For instance, the processing and firing functionality that is provided with the transitions of Petri nets.
Thank you very much. I don't see any more questions, so if you want to ask anything, let us know. So I'm looking at the participant list and at the questions list, but no questions.
I just recognized that I didn't turn on my camera, so I'm very sorry for that.
No problem. I think in the final recording, camera would not be shown at all, so no problem. Thank you very much for a very interesting presentation. This was incredible to see how it is possible to link the digital and the real world environment by using various approaches. And it was also very cool that you have shown us not only the slides, but also actual live stream from your laboratory, showing how by touching those cards, how by using RFIDs, you could show it in the real time, the results on the dashboard. So it was very cool that it was not only slide based, but it was real world demonstration. So thank you very, very much.
Thank you very much for the possibility.
So if there are no more questions, I would like to thank you very much for being with us on this webinar today. And I would like to invite you to our next webinar, which will take place in March. So bye-bye. Have a good day.
Thank you. Bye-bye.